So let's get the Fourier transform of some basic signals and apply Fourier transform properties if possible. Let's start with the unit impulse. X of t is equal to delta of t. Right? So x of f is equal to integral of x of t, but x of t is equal to delta of t times e raised to the negative j 2 pi f times t dt, evaluated from negative infinity up to infinity. Now, to simplify this expression, we have the shifting property for the unit impulse. Ano itong shifting property? Let's say we have integral of x of t times delta of t minus t naught dt evaluated from negative infinity up to infinity. The answer of this integral is equal to x of t naught. Okay? So this is the shifting property of the unit impulse. Okay, so applying the same principle dito sa right hand side ng equation natin. So this will be equal to e raised to the negative j 2 pi f times t is equal to 0. Okay, so e raised to the 0 is equal to 1. Okay, so in the time domain, we have delta of t, and in the frequency domain, we have a constant. Now suppose we have a constant in the time domain. So x of t is equal to 1. So gamitin natin yung synthesis expression natin. X of t is equal to integral of x of f times e raised to the j 2 pi ft df evaluated from negative infinity up to infinity. Okay? So, pag kinompare natin itong expression natin doon sa ginawa natin kanina sa pag-derive ng Fourier transform ng unit impulse, we can apply the same principle from the shifting property. And the logical answer for x of f in this case is that x of f must be equal to the impulse function delta of f. So pag in-apply natin siya dito, and again applying the shifting property, then the result of this integral will be equal to 1. So x of f is equal to delta of f. So if we have a constant in the time domain, then in the frequency domain, we have an impulse function, delta of f. Okay, so we could also apply the duality property. So alam natin that delta of t and the constant in the frequency domain are Fourier transform pairs. Now, if we have a constant in the time domain, so sabi ng duality property, dapat siya ay maging equal sa x of negative f. So that is delta of negative f. So again, galing siya dito and applying the duality property. But delta of negative f is also equal to delta of f, diba? Kasi we have an impulse centered at f is equal to 0. So these two functions on the right, delta of negative f and delta of f, they are equal. Okay? So pareho lang ang sagot by either using the synthesis expression and the shifting property or applying the duality property. Now suppose in the time domain we have this complex exponential function x of t is equal to e raised to the j 2 pi f naught times t. So pwede nyo siyang gawin, you apply the definition of the Fourier transform, or para mas simple, we can use our property. Okay? So, nakuha na natin that if we have a constant in the time domain, then in the frequency domain, that is an impulse function, delta of f. So, gawin natin, yung constant natin, multiply natin ng e raised to the j 2 pi f naught times t. Okay? And from the frequency translation property, then in the frequency domain, this will be delta of f minus f naught. So this is our answer. So similarly, kapag meron tayong x of t, which is equal to the complex exponential e raised to the negative j 2 pi f naught times t, then we'll have the following transform pair. So in the time domain, e raised to the negative j 2 pi f naught times t. Then in the frequency domain, we have delta of f plus f naught. Okay? So next, now let's say x of t is the sinusoidal function cosine of 2 pi f naught times t. Okay, so again, pwede natin i-apply yung Fourier Transform definition, pero magiging mas matrabaho yung pag-derive ng final answer. So gawin natin, we use the Fourier Transform properties in yung na-derive na natin na expression earlier. So express natin yung cosine function as a sum of complex exponentials. So cosine 2 pi f naught times t is equal to 1 half times e raised to the j 2 pi f naught times t plus e raised to the minus j 2 pi f naught times t. Okay? So, leading na itong ginagawa natin. Kasi kanina, nakapag-derive na tayo ng Fourier Transform for complex exponentials. So, idiretso na natin. In the frequency domain, x of f is equal to 1 half times yung e raised to the j 2 pi f naught times t, yung Fourier transform niya is delta of f minus f naught plus yung Fourier transform naman ng second exponential is delta of f plus f naught. Okay? So this is the final answer. We applied linearity. Okay? So linearity para dito and para dito sa constant. And then we also, well, basically we applied the Fourier transform pair definition earlier for the complex exponential. So in the time domain, again, we have a cosine function, and in the frequency domain, we have a pair of impulses. One is located at positive f naught, and the other impulse function is located at negative f naught. Both have a magnitude equal to 1 half. Let's do the same for the sine function. So x of t is equal to sine 2 pi f naught times t. So again, gamitin natin yung Euler identity natin. So the sine function is equal to 1 over j2 times e raised to the j2 pi f naught times t minus e raised to the minus j2 pi f naught times t. Okay? And then, diretso na ulit tayo sa frequency domain. So, x of f is equal to 1 over j2 times, so itong first exponential natin becomes delta of f minus f naught. Yung second exponential natin ay delta of f plus f naught. Okay? So this is the Fourier transform of our sine function.